Hey guys, in this video I'm going to show you how to retrofit a wall-mounted heat pump and air conditioner with a Nest thermostat. And this is the heat pump that I have in my apartment. It provides cooling in the summer and heating in the winter. It has a reversing valve so it can change the direction that it moves heat in. And then in the winter when it's very cold, it's difficult to move heat inside from outside. So it has an electric heating coil which helps for winter operation. And I haven't done this before, so it's a bit of a learning experience and discovery for me. A couple of my colleagues have done home improvements like this and they challenged me. I said, you know, you solve these equations and do all this stuff on the whiteboard, but you got to get your hands dirty and try something on your own. So I'm going to give it a shot today. And I have lots of information here, so I'll start with some of that and then we'll actually go into the unit and talk through what we're going to do and try to knock this out. So obviously you're looking at the heat pump now. I've collected some documentation on the unit. I opened it up and I found this document here, which is basically the technical data for the unit, and this was inside there. So that was a good starting point. And then I went online and found the manual, which has even more information. But what I was really looking for is how to interface with the unit. So there's an even more detailed document. This is about 3 or 4 times longer than the manual for architects and engineers. And in here I found more information about this optional interface module. And this sheet probably doesn't mean a whole lot to you, but I'll show you what this actually looks like when we go inside the unit because I have it here. Basically it connects to the auxiliary input on the unit and offers up terminals that will connect to Nest. And then I have the Nest instruction manual as well. And then I have the Nest thermostat. This is how it comes out of the box. So we'll look at how to connect all this up in a bit. And then I ordered a remote temperature sensor because really I don't necessarily need to interact with the thermostat. Everything's through the apps nowadays. So really what I want to do is get an accurate read on what the temperature is in the room generally, and I'm thinking about just leaving the thermostat right by the unit, maybe somewhere down here, perhaps even loose so I don't have to bother mounting it. I could leave it inside the unit wired up, and we'll see. I might change my mind as we go along on that. And then as far as tools, I have a multimeter so I can check the 24-volt control power to make sure the right things are happening. I have a set of wire strippers, and then I have screwdrivers and all that good stuff. And I have 18 gauge control wire. I only need to go a very short distance from here to the side, but I do need 6 conductors, and this is 2 conductor cables, so I'll have to use 3 lengths of it to get the job done. So with that, let's take a look inside the unit and just take the cover off. So as you can see, we have these auxiliary controls here. I don't know if this is close enough for you to see that. We'll get a closer view of that in a moment. But what I really want to show you is right underneath this aux controls component. There's this little white plug here, and that's where we're going to connect the optional interface module, which is this guy on the bottom. I didn't install it yet, I just put it in the slot. There's actually an open space here right below for if you want to add this option, but I ordered this separately. So this is what the module looks like. It's got this white plug, which is what we're going to put into here, and then these are the terminals that it offers up, which is pretty typical for a heating and cooling system, and hopefully we're able to just follow the instructions and wire it into that and we should be good. Alright, so I got the optional interface module connected. While the camera was off, I unplugged the power to the unit and I slotted the optional interface module in and I plugged it in right here. So that's all I did. And I have the goal of verifying that control voltage is getting from the unit to the interface module. So I'm going to do that with my multimeter here. So I'm going to turn this on, turn it to voltage. And I was originally testing for AC voltage, but I was getting a value and then it was quickly changing to 0, so that didn't make sense. So then I tried testing for DC voltage, and you're going to see that this is going to work. So I'm going from R, which is the power, 24 volt power, to C, and I'm going to the top because those are the only terminals that have wires on them. And as you can see, I have 27.9 volts DC, so that's good. And I have no voltage from the power to any of the others either. So, and I have no voltage on any of the others, so I should have 27 volts or whatever it is. So this is from R to G, which is to the fan, so there's no power getting to the fan. This is to the solenoid, that's also 28. And then nothing to the compressor, which we expect the unit's off, so all of these are going to be de-energized. That's just kind of the current standing of where everything is in terms of power getting to this module. If that's true, we should be able to get the fan going just as a test. I've made a small jumper, no big deal, just a little piece of wire here, and I'm going to connect the power to G, which is the fan, and we should hear the fan run if this works. There it goes. So we've just energized the fan. If I take that away, it should shut down, and it does. So that's basically everything we need now. We have RGB YWC ready to rock. Now we're going to wire that to the Nest thermostat, and then we can start setting it up and playing around and running it through some testing. What I'm actually going to do is unplug the unit again, unplug this, and take it away so I can work at it neatly at my table with good lighting and not have to work here on the floor. I think I'll do better work in that environment. So let's see what's next, and we'll come right back here and put it all together in the next segment. In the last segment, we verified that the interface module was communicating with the unit and that we had control voltage. But what I failed to mention was that the first time I tried that, it didn't actually work. There was a dip switch here. There are 6 dip switches, and they were all in the off position, and I had to change one of them, the third one, which says class 2. I turned that on, and I realized that when I tried to measure and didn't find any control voltage, and then I read in this document here that to get the remote thermostat working, the class 2 mode setting has to be set to on. So that's how I knew to turn that dip switch on, and that's how we got that control voltage. So I just wanted to point that out. If you are working on a GE Zoneline model air conditioner and you're doing the exact same project I'm doing here today, then you won't get any control voltage until that dip switch is turned on. So now that that's done, I wired up the Nest, or at least I pre-wired it. I haven't done any testing yet, but I just wanted to show you what that looks like before I put it all in. So on the interface module, it looks like this. Really no surprises. We have those 6 terminals, just like we said we would. And I only had 2 conductor control cable, so instead of 6 conductor, you see the 3 2 conductors, and I just kept track of black and white. I did label the cables with 2 different labels, so you can see here you have a Y and what is this one? OB, which is really O. So anyway, I put the labels on there so I have a 50% chance, and then I just have to look at what's black and white. And then on the other side, I have the Nest thermostat, which kind of looks like that. That's how that wires up. Really no surprises there. So if you know the alphabet, you can pretty much match these up, but I wanted to at least show this before I move forward. I'm going to now put this back in. I'm going to connect this cable permanently, and then I'm going to get the thermostat tested and install the app on my phone, and hopefully we can control this unit from the phone. Let's see how we do. Okay, as you can see, I've wired up the Nest thermostat as discussed with the wiring configuration that we showed before. And I've plugged the unit back in so that it has power. Then I went into the settings of the thermostat and went through all the settings. It's pretty intuitive to configure the Nest. The only thing that was interesting about my setup is that I also have the remote temperature sensor, so I set it up to communicate with this as well. You know, you have to connect it to your Wi-Fi and all that stuff. But the really interesting part for me was around the testing of the unit from a mechanical perspective to make sure that this wiring was right. There's a sequence in Nest, when you first set it up, you go into equipment, and I almost don't want to go into too much detail on this because I'm not able to replicate it and demonstrate it for you at this point. It worked the first time I went through it, and now everything works, but I can't seem to show how the test works. But the first time you set it up, you go into settings and then go to equipment, and then it shows you the wiring configuration, which is consistent with what we showed before, and everything's connected and the control power is good. I confirmed all this with the meter, and then continue, and then you select what kind of system you have, which I did, and then continue, and then you can test. There's this test function, and you go one by one testing each of the functions. So first you test the heat pump, which is just the compressor with the solenoid and the fan, not the auxiliary heating, not the W contact. Then you test the auxiliary heating, which probably also comes with the solenoid, definitely brings the fan and the compressor. So you're basically getting all four, G, B, Y, and W at that point. And then emergency heating, I don't know if that would be applicable unless it was very cold outside, but theoretically it could be. But if you can run the auxiliary heat, then you can run the emergency heat, at least in principle. And then the last one is heat pump cooling, which I wasn't able to test because it's too cold outside to run air conditioning mode. But I trust that it will work. If the compressor runs and the fan runs, then cooling is in some ways simpler than heating. And then the fan itself, which is the only test that I was able to replicate after the initial setup. So things that were interesting and takeaways from this project for me, the first one is that I would use smaller control wire. I used 18 gauge wire. I might go for 22 gauge. I had to actually clip a couple of strands just to make the wires fit in the terminals, and maybe that's specific to this optional interface module, so not too much of a concern there. And the other challenge was around this testing. I really wanted to demonstrate in this video what the testing procedure was like and show that each of the functions work, but unfortunately the test mode seemed to interrupt the operation of the unit and was unsuccessful after the initial attempt. But the unit does control to the temperature set point that I put into the stat or into the app on the phone, and it works to achieve the set point, and then it turns itself off, and the schedule function works. So all the functionality is there except for the testing. I don't have any strong theories as to why that would be. Maybe it's not too important because it works. The only thing that I could think of is maybe the terminals, the pair of terminals, because it actually tells you in the setup mode that it wants G, which is the fan, and Y, which is the compressor, or W, which is the auxiliary heat, but it never says that it's testing B, which is the solenoid. So I think it might be the absence of B where the unit is holding itself out, because to run the compressor in conjunction with the fan without bringing on B, without firing the reversing valve to put it into heat pump mode, it's going to run as an air conditioner, and that wouldn't be desirable because of the outside temperature. So I think the unit may know that and is holding it out, whereas for some reason in that initial test mode it wasn't held out. That's just the theory. If anyone has any other ideas, I'm open to hearing it. And again, in takeaways, the dip switch, having to set that class 2 dip switch to get the control power to come through to the interface module, was a key point in getting this all to work. Other than that, I'm pretty happy with how everything's working. I have a heating system that I can now control and do all kinds of fancy stuff with, so that's exciting. I'm going to put the cover back on this bad boy, and I'll probably just leave the thermostat loose for now, but eventually I'll neatly run the cables and tidy it up and either pin it to the wall or pin it to the side of the unit. But that's it for this video. Hope you guys enjoyed, and see you in the next video. We'll get back to solving problems.